Good morning, everyone. I'm super excited to be here today in this in-person trade show. So today, I'm going to talk about the feature discovery that empowers your feature stores. Before my presentation, let me just briefly introduce who we are. dotData, we are located in San Mateo, California. We are a Series B company, raised $75 million to date. dotData is feature discovery platform, and we help all AI machine learning driven companies to build high velocity, scalable, and agile AI machine learning practices through our feature discovery technology. The first presentation this morning, Ben told us 76% of executives are facing challenges of scaling AI machine learning. So hopefully today, my presentation give you a solution to tackle this problem. So let me start from this statement. Feature is the interface across stakeholders. Our telco customer wants to sell their payment application to mobile subscribers. And they found that mobile subscriber in Algeria who signed up from iPad are much more likely to sign up the payment application. Our steel manufacturing customer found that if the amount of certain metal is larger than this threshold, the final steel quality is good and with less energy consumption to heat a chamber. So this is a feature that we are talking about. Line of business need a feature to extract actionable insight from data. Data scientists need high quality features to build more accurate machine learning models to make the better prediction. By the way, data engineer is responsible for building a stable feature pipeline in production. So they need to build a robust and a stable feature pipeline. So feature is interfacing across different business stakeholders. And the question is, this is such a critical asset, and Ben said data as a product. Right? How can we build this feature across organization in a scalable manner? So this is a topic I want to cover today. When I talk about the feature discovery, feature engineering, sometimes audience are a little bit confused. Like, which stage of data are we talking about? So I want to set the right expectation to this presentation. So there are the famous 3 stages of the data proposed by or defined by Databricks: bronze, silver, and gold. So bronze, this is a master data management issue that we are not going to touch today. So today, we are starting from silver data, silver to gold to the feature table. So this is today's focus. So from silver data, what do we mean by feature discovery, feature engineering from silver data? Let's look at this simple example. This is open data, credit card analysis of check bank. The task is to predict client loan default. Order table, loan table, account table, district table, transaction table, card table, and so on and so forth. There's 8 tables. All tables have different cardinalities. The data are kind of structured, but really not well cleaned. And as you can see, there's a timestamp information in many tables, so you have to handle the relationship across the time. So when we start from this silver data to discover features, there's mainly 2 steps. One is to transform multiple tables into a single flat table, single flat feature data. In this stage, first of all, you have to handle the certain data quality and cleansing issue. Once you aggregate the data into the single flat table, you cannot go back to the original data value. So at this stage, you have to make sure that you are performing the final data cleansing to have a high quality feature. Data schema issue, value cleansing issue, missing value, data skewness, and so on and so forth. There's a lot of different type of data quality issue, but different from bronze data quality. But silver data still have a lot of top data cleansing that we need to perform. Another one is multi-table transformation, normalization, denormalization. We have to join the table, aggregate a multiple record to the one single value, or you have to consider temporal relationship, or you have to combine the information from multiple tables. And now, once you come to the single flat table, you can further develop high-order features. Right? You apply the categorical encoding, numeric binarization, timestamp featureization, or you can even apply more advanced technique, polynomial transformation, dimensional reduction, neural encoding, and so on and so forth. And feature discovery from silver data needed this kind of steps. And this process is very, very time-consuming, challenging, and error-prone. I want to highlight the 4 challenges that dotData is mainly tackling. One is data is diverse, complex, and dirty. So silver data is somewhat already structured, but not yet perfectly cleaned yet. Every time when data scientists build a feature from silver data, they have to do a lot of manual and customized work to handle this data. So silver data still have the data-related issue. Another one is domain knowledge. Right? When you build the features, you have to apply your domain knowledge. However, data science team is usually not necessarily proficient in business problem, and they need support from line of business to get the domain expertise to build the features. But this iteration between data science team and line of business is usually very expensive and time-consuming. But now, you put a domain knowledge, you do a lot of statistical validation, you come up with great features. Next challenge is, you have to put this feature into the production pipeline. And then what is going to happen in practical places, data scientists bring the Jupyter notebook to the data engineering team and ask, hey, I discovered a very impressive feature, can you productionize it? And then a lot of communication start to happen between data science team and data engineering team to really productionize this feature. Last but not least, you productionize the feature, you build a feature table, that's great. However, data is changing over time. You may have a new data source from which you want to explore new features, or you want to solve a new business problem, new use cases, and you need new features. So feature discovery is in nature iterative and continuous process. So dotData, we approach these challenges using some AI algorithm we developed, which we call the feature factory. So let me explain what it is in the next few slides. So the key concept is we applied some supervised technique, and our feature discovery identifies features that are most impactful to your target variable. So first, input is the silver data, a lot of tables with a complex relationship, and you have to put a target variable. And then our platform automatically explore millions of feature hypotheses by searching this complex relationship, and then do a lot of statistical validation, selection, and optimization in some case to discover the feature set for your target variable. Of course, during process, a lot of different techniques needs to be applied. For example, feature quality is very important. We have to avoid overfitting. We want to avoid a collinearity of the features or redundancy of features. Some features looks very similar, and we want to eliminate those kind of redundancy. Or, as I mentioned, silver data quality is usually not very good enough. So we have to apply a lot of data cleansing, feature cleansing kind of techniques. Or one of the big pain for the data scientist to build the features, which is time-stamped, is avoid a leakage. right? A lot of leakage happen in the temporal horizon. And also, you have to make sure the point-in-time correctness of the feature when you train the model. So dotData, our feature factory, is basically the algorithm to address all these problems in a single pipeline. So let me a little bit briefly review how it works. First, you put the silver data and target variable. Then our algorithm is wrangling data, explore the feature, and provide out of millions of hypothesis candidates, we provide tens to hundreds, a most promising feature to the data science team. And this chart is actual example when we apply our algorithm to this check bank data. The first feature is a proportion of records that satisfy type equal to withdrawal in the last 6 months during weekday. So which means like customer who have a lot of withdrawal transaction during weekday in the last 6 months has a much higher likelihood for the default. And with this feature importance score and of course a lot more feature metrics that dotData statistically validated, data science team can investigate, inspect these features, and then find the most relevant one for their business. The second point that I want to highlight is that this kind of approach, applying AI technique to discover a feature, is very, very unbiased, which means that your domain feature is very, very strong, and you have to put a lot of domain expertise. At the same time, the domain knowledge have its limitation, like you cannot explore millions of features. So this kind of AI feature discovery approach can really complement your ability to explore bigger feature space and find some patterns that you cannot explore by yourself. Now, you discover features. It's turn for data engineer, right, to productionize the features. So this kind of AI feature discovery technology can generate the production-ready feature queries. So it's no more required between data science team and data engineering team. Hey, this is my notebook, and can you productionize my feature? But rather, the query can be automatically generated that can be put into the production. The last point 4 is more like repeatability and scalability. This is AI-based feature discovery, but there's a lot of course, customization and control that you can play with to discover different type of features that you prefer. But at the same time, important part is once the configuration is provided, everyone can get the same result. So it's very, very repeatable process. You just need to change the target variable, then you can discover the new feature set. At the same time, this saves a lot of time for data scientists and data engineers, eliminate a lot of manual effort, and this makes the team very scalable to discover features. In the last couple of slides, let me explain how this works in entire AI ML workflow. So you have the source data in a silver stage, and the feature discovery engineering, and you do the machine learning. This is iterative process, and once you build a model, you put the model into the ML ops product. This is a basic current workflow in most of the existing organizations. So this is how dotData feature discovery fit in, plus feature store. So what dotData cover is basically 1, 2, 3. We discover features, and we provide some evidence of feature. Data science team can validate our features with AutoML or their preferred machine learning algorithm, and then they can generate a production-ready feature query. Now, this is a new framework in the industry, like feature store comes into this ecosystem. Like, for example, Databricks feature store, Amazon SageMaker feature store, Tecton, HopsWorks. There's many good feature store product in in the industry now. So our feature can be just plugged into this feature store, register query into the feature repository, generate the features, and store feature table. With this, our feature discovery make this process more scalable, repeatable. Feature store makes feature more reusable. With this, by combining these two, data science team can focus more on building better model and better predictions. This is just last slide, practical implementation example, not just conceptual talk. How, for example, can we implement this on Databricks? Your data is in a data lake, and then you load the data onto the Spark data frame on a Databricks notebook, and then you just pass this data frame to the dotData and your target variable. And you don't need to move the data from Databricks. All the computation and the data processing happening on a Databricks platform. And then you discover features. And then this experiment is managed, you can manage this on an MLflow framework. And once you discover features, this production-ready query or feature table, dotData generated, can be just plugged into the feature store or data live table. So this is how our feature factory can be deployed on Databricks, but also, of course, our feature factory can be work on a different data platform as well. So it's time. So I'm just wrapping up my presentation. So I talked about the feature factory, and today AI machine learning development is more like a tailor-made model. Every use case requires a custom, manual feature discovery process. With feature factory and feature store, we can change it to the more mass production model, like make it much scalable and high velocity model. That's all my presentation. And you can find me by seeing my blue hoodie. And we have the exhibit booth. So please come to our booth and we can discuss more details. Thank you very much.